in the presence of catalyst, that is cupric chloride at 723 kelvins nearly, adduce corresponding byproduct water plus chlorine gas is liberated. Now to get Cl2, yeah, we want your total oxygen is 2 is there, that's why I take here the 2 moles. Now here oxygen atoms only 2 are there, here 2, but hydrogen atoms 4 are there, that's why it is multiplied with this 4 if we can take like. Now here 2 H2O, 4 hydrogen atoms balanced, chlorine atoms are take here 2 moles, now balanced. So this chlorine is prepared by using hydrochloric acid, hydrogen chloride, and atmospheric air is reacted with this CuCl2. It was explained by Deccan scientist. That's why this is called a catalytic oxidation. Catalytic oxidation of HCl, hydrogen chloride. So what happens here on catalytic oxidation of hydrogen chloride, give equation or what is the gas liberated in this? Maybe they'll ask like. So these are the some important methods by using manganese dioxide, by using electrolysis process, by using Brin solution yesterday explained, and this is the Deccan's process by using hydrogen chloride. Now the obtained Cl2 gas is a greenish yellow color gas and suffocating gas. Suffocating gas it is. It is 2 to 5 times heavier than air. Heavier than air. It is soluble in water. It is soluble in water. So these are some important points about chlorine. Now that chlorine chemical properties. There are chemical properties of chlorine. Very, very important properties, chemical properties. So are the chlorine Cl2 react with metals. It reacts with metals. Reacts with non-metals, or reacts with hydrogen or hydrogen containing compounds. Hydrogen containing compounds or hydrocarbons. Hydrocarbons. So based on this, your chlorine shows a wide applications. Different uses are there for chlorine. So how it react with chlorine react with metals, non-metals, compounds containing hydrogen or hydrocarbons, and with some other metals, some other non-metals, how it reacts will explain here. Okay. First some metals, chemical properties of chlorine and chemical property of chlorine. First one is here with metals. First one is with metals. Here metals means alkali metals take here the sodium. Its valence is 1, combining capacity 1, shows +1 oxidation state. It combines with chlorine. Now it is directly converted into gases, converted solid sodium. Solid is converted into sodium gaseous like. That is direct conversion of solid to gas is called a sublimation process. The obtained gaseous sodium is reacted with chlorine, also a gas. Take care the 2 moles. gives NaCl, sodium chloride. So it is a metal, it is a non-metal, it gives a salt. It is a ionic salt. Your sodium is +1, chlorine is -1 by crisscross method. It is a first group element. All first group elements like potassium react with chlorine. It is a gas. Now it gives potassium chloride. Not only sodium, potassium, rubidium, cesium reacts. First group. Similarly, second group elements like magnesium combines with the chlorine. This is also in a gaseous state. Now gas gives magnesium chloride MgCl2. So the magnesium is +2, chlorine is -1 by crisscross method. Like Ca plus Cl2, it gives CaCl2 like. Now here the aluminium react with the chlorine, it gives AlCl3, aluminium chloride. Here take 2 moles, 3 moles, 2 AlCl3. Here Al plus 3 and Cl is -1 by crisscross method. It gives Al1Cl3. So are the chlorine halogen react with the corresponding metals, it gives corresponding salts. It also reacts with the non-metals. How it reacts with the non-metals? Already given in 15th group elements and in 16th group elements reactivity towards halogens. Like here phosphorus react with chlorine, it gives corresponding PCl3, phosphorus trichloride. It is a non-metal. It is a non-metal and chlorine also a non-metal. Now here the 4 moles like 12, take here the 6. Also here the P4 react with excess amount of Cl2, it gives PCl5 like. Now here the 4 moles 20, here are 10. Already these two reactions explained. Now here the sulfur acid react with chlorine, gives S2Cl2. This is here 8 moles are there, take 4 S2Cl2. Now here take 4 moles. It is also called a sulfur monochloride like S linkage, here chlorine and chlorine. Sulfur monochlorides dimerases, they are explained. Halogens like sulfur combines with halogens, it gives ESF, ESF4, here the ESF6 like. Here hexafluoride, tetrafluoride, monofluoride, difluorides explained. Now it is sulfur monochloride dimerases like here the Cl sulfur contains 6 valence electron, 1 valence electron is bonded with this chlorine. One more sulfur chloride again combines with this, it forms a covalent bond like between this dimeric structure exists. Sulfur monochlorides are dimerases like chlorine reacts with metals as well as non-metals. And one more point given now, chlorine react with hydrogen and hydrogen containing compounds. Hydrogen means directly here reactivity towards hydrogen given on reaction. Fluorine is directly reactive with hydrogen, it gives hydrogen fluoride in dark condition also, already given reactivity towards hydrogen. Halogens directly react with hydrogen. Fluorine directly react, reactivity is more. Now with hydrogen, fluorine directly react with hydrogen in the presence of dark also or sunlight also, gives hydrogen fluoride. Reaction is a fast reaction. But here we are discussing about chlorine, that's why here chlorine react with hydrogen in the presence of sunlight, not in the presence of dark. So here in dark condition, in dark condition. Now this reaction is somewhat slow. In sunlight, diffused sunlight, reaction is fast. Now it gives 2HCl, hydrochloric acid. So third model is chlorine reacts with hydrogen or hydrogen containing compounds like H2Es. It is hydrogen sulfide react with chlorine. It gives hydrogen chloride plus sulfur precipitate is formed. Similarly, it combines with hydrocarbons. So generally, hydrocarbons means we know alkanes. Alkanes reacts with chlorine or halogens. It gives substituted products. These are the saturated hydrocarbons. Whenever alkenes or alkynes, they are the unsaturated hydrocarbons. Reacted with chlorine, it gives addition reactions, addition of products. So already in first year, in 11th standard, in hydrocarbons explained about hydrocarbons, alkanes, alkenes and alkynes. One of the most important reaction first you see in 11th standard, chlorination of methane, halogenation of methane, alkane. Very, very important reaction, that is halogenation. Halogenation of methane or hydrocarbon like alkanes like. Now, particularly if we can use chlorine, that is called a chlorination. Chlorination of methane. Now that methane is reacted with, it is an hydrocarbon, alkane react with chlorine in the presence of UV light, not in dark condition. Free radical mechanism takes place. It gives HCl plus CH3Cl is formed. Now this is the substituted product. Chlorine is substituted by replacing hydrogen. Similarly, if we can take some same obtained product is reacted with excess chlorine, same it gives HCl plus CH2Cl2. Now CH2Cl2 is reacted with again Cl2, gives HCl plus CHCl3. It is called a chloroform. Now CHCl3 again react with XCl2, gives the CCl4, carbon tetrachloride. So are the hydrocarbon methane containing 4 hydrogen atoms. These 4 hydrogen atoms are replaced by these chlorine atoms. It gives the corresponding substituted products: monochloro, dichloro, trichloro, tetrachloro hydrocarbons. These are the substituted products. While substituting, byproducts are liberated. That's why these are called a substituted chemical reactions. These are hydrocarbons. They are the saturated hydrocarbons. They are alkanes reacted with these chlorine with reacts with chlorine. It gives substituted products. Whereas unsaturated alkenes reacts with chlorine, CH2 double bond CH2 with Cl2. It gives the addition products, not the substituted. Means your pi bond ready to break either this or this side. Then it gives CH2 bond CH2 single bond, here one Cl and here one Cl. There is no byproduct, only one product. Added addition reactions takes place. Addition reactions. So very, very important question in first PUC 11th standard in hydrocarbons, that is in aromatic hydrocarbons, that is chlorination of benzene, halogenation of benzene. So halogenation of benzene is nothing but Yeah, different conditions are there. Halogenation of C6 and H6 benzene. Yeah, under these substitution conditions, benzene reacts with Cl2 in the presence of anhydrous AlCl3 aluminum chloride or AFeCl3. It undergoes electrophilic substitution reaction ESR. Chlorine undergo dissociation. It gives Cl plus and Cl minus. It is an electrophile, it is an nucleophile. This electrophilic substitution reaction takes place under these conditions. Without this, by using ultraviolet light or by using any sunlight conditions, by using other conditions, we'll get the different products. That is already given addition products, that is 666, lindane, gamaxin. So depending upon the conditions, you'll get the different, this is also a electrophilic substitution. Your HCl from benzene, one hydrogen atom react with the Cl, it gives HCl plus chlorobenzene is formed like this is. Formula is, its formula is C6H5Cl. This is very, very important reaction. Chlorination of benzene, halogenation of benzene. These are from organic part. So in inorganic, in 17th group elements, halogens are there, like chlorine is there, chlorine properties, all these. So chlorine reacts with metals, non-metals and compounds containing hydrogen as well as hydrocarbons, like with saturated and unsaturated compounds, alkanes and alkenes. Some more other important reactions we'll discuss after this, all this. This is a very, very important property with alkali solution. With alkali solution means reacts with sodium hydroxide NaOH solution. Or in our syllabus, one more important given CaOH taken twice solution. Slakeline calcium hydroxide. Okay. Now here chlorine reacts with sodium hydroxide NaOH. This is in aqueous medium. This sodium hydroxide is generally, it is cold and dilute condition, not concentrated, cold and dilute. Gives corresponding sodium chloride, sodium hypochlorite plus water is formed, H2O is formed. Very, very important reaction, listen carefully. So are the chlorine atoms 2 are there here, okay. Sodium only 1 is there, that's why it is multiplied with the 2. Your oxygen atoms are 2 are there, hydrogen, everything is balanced. When sodium hydroxide alkali solution is cold and dilute condition, if it is same chlorine, same alkali solution NaOH, if it is in hot and concentrated, just on heating, then it gives NaCl plus NaClO3 plus water is formed, H2O is formed. So in both the cases, here and here, sodium chloride is common, difference is this. That's why in examination, they will miss these and they'll ask, complete the following reaction. When it is reacted with dilute condition, sodium hypochlorite, when it is concentrated sodium chlorate. Now here chlorine atoms are 2 are there here, oxygen atoms here 3 plus 1, 4 are there. That's why here we want 4. Or take here 6 moles like If you can take 6 moles, your 3H2O water required. Now 6 balanced oxygenator. Now here the Cl2 are there, balanced. Take here the 3 moles, 6. Now here take here sodium 6 required. Take here 5, not balanced. Here take 5, it is balanced. Like 6 Na 5 plus 1 balanced. Chlorine 6 are there, 5, 1 balanced. Clear? Now once we can observe this chemical reaction, very very important chemical reaction, your chlorine oxidation state is here 0, here in this case chlorine oxidation state is -1. Now here chlorine oxidation state is here +1 because sodium is +1, oxygen is -2. To satisfy this is the +1. Now chlorine, once we can observe here to here -1 and the same chlorine here to here +1. This is the chlorine here to here removal of electron. Removal of electron is called a oxidation. It is a reduction reaction. Only one chlorine atom undergo both oxidation as well as reduction reaction. That's why this reaction is called a disproportionation. A disproportionation reaction. Now, very very important concept is when it is reacted with a cold and dilute NaOH or alkali solution, that a chlorine or halogen atom changes from where to where means 0 to -1 and 0 to +1. So oxidation state changes from 0 to -1 and 0 to +1 here. 0 to +1. Very very important. Whereas in this case, same it is also a disproportionation reaction. Now chlorine 0, 0 to the -1, also here the reduction reaction. Now here the 0 to the here to here chlorine oxidation state is +5, that is oxidation reaction takes place. Now when chlorine is reacted with the excess amount of hot concentrated NaOH, now here the chlorine oxidation state changes 0 to the -1, 0 to the +5 oxidation states. These are very very important reactions. So when it is reacted with alkali solution, chlorine is reacted with alkali, two cases are there. One is with dilute condition, another one is hot condition. Not only chlorine, even bromine Br2 react with 2 NaOH gives NaBr, sodium bromide plus NaOBr plus H2O is formed. Now here Br2 react with 3 moles plus 6 NaOH gives NaBr, 5 NaBr plus NaBrO3 plus H2O is formed. 3H2O is formed. Not only Br, iodine also same. Iodine, this is the concentrated condition, this is the dilute condition. Same thing, iodine react with 2 NaOH and here the 6 NaOH, it gives the same products. Like it gives same products means these are common, but here it differs. Like NaOI and NaIO3 are formed. Whereas in case of fluorine, it is not happen like it differs. So in case of chlorine, bromine and iodine, when it reacts with alkali solution with dilute condition, it gives dilute condition, it gives NaOCl or your NaOBr or NaOI is formed. These are called sodium hypochlorite chlorides. This is the bromides. This is the iodides. Sodium hypochlorite, sodium hypobromide, sodium hypoiodide. It is under dilute conditions, whereas in concentrated conditions, it gives NaClO3, NaBrO3, NaIO3. These are sodium, not hypo. Simply these are called chlorates. This is the sodium bromate. This is the sodium iodate. This is iodate. So chlorine, bromine and iodine reacts with the cold and hot condition alkali solution and give the same compositions. But whereas in case of fluorine, it is somewhat different. Look at the different products. So here fluorine is react with the important reaction. This is fluorine is reacts with NaOH sodium hydroxide. That is in a dilute condition, it gives sodium fluoride NaF. This is. And here sodium fluoride plus, now here the HF plus OF2 is formed. Whereas here in case of 2 NaF and oxygen atoms are 2 are there. Sorry, not here H2O. So the 2F2 plus 2 NaOH in dilute condition, it gives only sodium fluoride and OF2 is formed. Whereas in case of concentrated conditions, it is concentrated condition, it gives here 4 NaF plus H2O plus oxygen gas is liberated. That is very, very important. So this reaction with alkali solution means NaOH or KOH or like a slake line. Only in our syllabus and textbook chlorine relation given here, NaOH, cold and hot conditions. But here bromine, iodine and fluorine all halogens properties given to you. So our chlorine, bromine and iodine gives different products like hypochlorite, hypohalides and chlorates, whereas in case of fluorine, it gives oxygen difluoride and oxygen only. These two are very, very important reactions. Okay. The next one is with slake lime, CaOH taken twice. So here chlorine bleaches the calcium hydroxide, then it gives corresponding bleaching powder combination. It reacts with the alkali solution like. See here, Cl2 react with the slake lime, CaOH taken twice. Calcium hydroxide are also called slaked lime is reacted with chlorine. It gives CaOCl taken twice plus CaCl2 plus H2O is formed. Here 4 moles are there, that's why take here the 2H2O. So generally, while writing a chemical reaction, this calcium oxychloride, generally it is called a bleaching powder formula. Bleaching powder. But the original composition of bleaching powder is composition of bleaching powder is CaOCl taken twice, or the CaCl2, CaOH taken twice, 2H2O. This is the composition of a bleaching powder. If they'll ask in objective or theory, better you remember this composition. Most important. When chlorine is reacted with calcium hydroxide, slake lime, gives corresponding oxychloride like CaOCl taken twice plus CaCl2 H2O. Along with this calcium hydroxide also trace amount present here. That's why CaOCl taken twice, CaCl2 and CaOH taken twice, 2H2O is the original composition of bleaching powder. Then after this reaction with the alkali solution, one of the most important reaction is reaction with ammonia. With NH3, this is also very important reaction. Here the Cl2 is reacted with NH3 ammonia. It gives ammonium chloride plus nitrogen gas is liberated. When now this ammonia is in excess, we can take like very important, just like sodium hydroxide excess limited or hot and cold condition, like here NH3, if we can take excess, take here the 8 moles. Here 2 is there, take here the 6 moles, 6 Cl required. That's why take here 6 means 3 moles, 3 Cl2, this is, will get. So ammonium chloride and nitrogen gas is liberated. So the chlorine is also used in the preparation of ammonium chloride. If it is chlorine is excess, yeah, this is the Cl2, this is the excess. Instead of ammonia and NH3, it gives NCl3 like here HCl plus NCl3 is formed. Now here NCl3 means here only hydrogen atoms are not NCl3. NH4Cl plus NCl3 is formed. Now take here the 2 moles. Now here NCl3 means around nitrogen 3 chlorine atoms are there, like 3 chlorine atoms. This is the Cl and Cl and Cl. This is the nitrogen trichloride. Nitrogen trichloride. This nitrogen trichloride acts as an explosive compound. Acts as an explosive compound. So these are the some important chemical properties. See here, how much here? NH3. Here are these two reactions reacted with the Cl2. It is excess. Here it is excess. How much here? NH3. It gives 3 HCl, like, sorry, 3 HCl, hydrochloric acid. Now here, if it is chlorine is excess, we'll get NCl3. If it is ammonia excess, we'll get the nitrogen gas. These two are very important reactions. So are the chemical properties of chlorine with the alkali and with this NH3, like ammonia molecule, it gives the corresponding nitrogen gas and nitrogen trichloride. It acts as an explosive compound. It reacts with the metals, it reacts with the non-metals, it reacts with the alkali solutions. Okay, next one is or the Cl2 acts as an oxidizing agent, as well as bleaching agent, oxidizing and bleaching agent. In moisturized condition, like Cl2 is dissolved in water H2O, it gives your HCl plus HOCl is formed. That HOCl again decomposes, it gives HCl plus nascent oxygen is formed. This is freshly prepared oxygen, nascent oxygen. Now, here by taking these two reactions, here HOCl and HOCl cancel, gives Cl2 plus H2O gives 2HCl plus nascent oxygen. So, due to the liberation of nascent oxygen in aqueous medium, water condition, this chlorine acts as an oxidizing agent and as well as bleaching agent. So, the bleaching agent is nothing but bleaching agent. It decolorizes some colored substances, colored organic compounds. Whenever the colored substances like vegetable oils or vegetable colors or hydrocarbons, colored compounds reacted with chlorine in the presence of water, all these are produced nascent oxygen atom, react with these oxidizes, it gives the colorless compounds, that is bleaching agent. Also acts as a sterilizing agent to kill the germs, chlorine. Now, some important oxidizing properties are there. We'll discuss 2 to 3 important oxidizing properties on the basis of these chemical reactions. When chlorine is dissolved in water, it gives hydrogen chloride and hypochlorous acid. Again, this hypochlorous acid again react with again decomposed, it gives hydrogen chloride and nascent oxygen atom. So, due to the evolution of this nascent oxygen, it acts as both oxidizing as well as bleaching agent. Then some important oxidizing properties on the basis of these. Here chlorine oxidizes sodium sulfite to sodium sulfate. One important reaction is it oxidizes, Cl2 oxidizes your Na2SO3 to Na2SO4. This is your Na2SO3 sodium sulfite react with chlorine in the presence of sulfuric acid H2SO4 against Na2SO4 plus HCl is formed, 2HCl is formed. In acidic medium or in the presence of water like H2O. So these two are oxidize, means react with each other, it gives nascent oxygen atom. That nascent oxygen atom react with this, it forms Na2SO4 and 2HCl. So the sulfite ITE is converted into ATE, sulfates, so oxidizes. Now here it oxidizes, Cl2 oxidizes ferrous sulfate to ferric sulfate, Fe2SO4 taken thrice. Now similarly, your FeSO4 reacts with H2SO4 in the presence of Cl2, it contains water, then it gives Fe2SO4 taken thrice, means here 2 moles. Then 2HCl hydrochloric acid is formed. Now here third one is Cl2 oxidizes your SO2 to SO3, sulfur dioxide to sulfur trioxide, like Cl2 in the presence of water react with sulfur dioxide. It gives sulfur trioxide plus 2HCl, hydrochloric acid is formed, because here H2O in the presence of Cl2, it creates a nascent oxygen atom that is reactive with the SO2, it forms SO3. Then one more is there, that is iodine is oxidizes to iodates, IO3. Same similarly, better you read from textbook all the chemical reactions. Finally, uses of chlorine. See here, uses of Cl2, chlorine. So many different uses are there industrially and in organic chemistry in hydrocarbons. In the preparation of, for example, main important preparation of tear gas, that is CCl3NO3, this is tear gas. And second one is mustard gas. Mustard gas, that is ClCH2 taken twice, yes, mustard gas. Third one is poison. This is PHOS, poison, that is COCl2. So some important useful industrially useful compounds, chlorinated compounds are prepared by using chlorine gas. Along with this, we can use chlorine is used to prepare HCl, is used to prepare ammonium chloride NH4Cl, or to prepare some your corresponding caloric, some important salts of like NaOCl3, sodium chlorate, potassium chlorate, like, or perchlorate like NaClO4 or KClO4, like this. Now it is used, it acts as an oxidizing agent, bleaching agent, as well as sterilizing agent, and as laboratory reagent. These are the some important uses of chlorine. So remaining some more other examples, read from textbook. These are major, main important, which are useful compounds. Maybe they'll ask in objective examination. These are the some important points about chlorine, preparation of chlorine, properties of chlorine, and uses of chlorine. The next one is hydrogen halides. Hydrogen halides already explained to you. Important hydrogen halides under reactivity towards hydrogen. So here reactivity towards hydrogen. So reactivity towards hydrogen means it forms corresponding hydride, 17th group hydrides. They are generally denoted as HX, HF, HCl, HBr, HI. These are some important hydrides or 17th group elements. Among these acidic strength, basic strength like reactivity order, everything given to you. Among these inner silvers, here HCl is there. All these are termed as a hydrogen halide. So this hydrogen halide is generally in pure state. In pure state, we can term as hydrogen halide, like hydrogen chloride. Hydrogen chloride, formula is HCl. This is in pure state. Pure state. When we can term as a hydrochloric acid. Hydrochloric acid means when HCl is dissolved in water, then it gives H3 plus O plus Cl minus. This combination is called, or HCl aqueous medium is called a hydrochloric acid. Hydrochloric acid. That is the difference between hydrogen chloride and hydrochloric acid. Please remember this condition, difference between hydrogen chloride or hydrogen fluoride. This is in aqueous medium. Here the HCl, now here the HCl in aqueous dissolved condition. This is hydrogen fluoride, hydrogen chloride, but it is called a hydrofluoric acid. It is called a hydrochloric acid. So such a halogen acids like hydrogen halides, when dissolved in water, it gives corresponding hydrated halide ions. They are called a hydrochloric acid. Among these, in our syllabus, this hydrogen chloride is there. This hydrogen chloride first prepared in the laboratory by Glober scientists. Glober scientists prepared this hydrogen chloride by using Glober method. In this Glober method, first only one method is there in this textbook, preparation of hydrochloric acid. Now salts of sodium, NaCl, is reacted with sulfuric acid. It gives corresponding sodium hydrogen sulfate plus hydrochloric acid is formed, HCl. Then HCl is prepared in a vapor phase. Again, maybe the obtained your NaHSO4 sodium bisulfate again react with some more excess amount of this. It gives like Na2SO4 plus HCl is formed. Hydrochloric acid is formed. And one more method is there. Dewey scientists prepared already direct combination, that is. Here the Dewey method, scientists directly prepared, that is direct combination of Cl2 with hydrogen in the presence of sunlight. So directly chlorinase react with the hydrogen gas, gives in the presence of sunlight, gives corresponding hydrogen chloride to HCl. This is. So these are the two important preparation methods are present in our textbook. That is Glober method and Dewey's method. Glober scientists prepared this hydrogen chloride by the acidification or the direct combination of sodium salts, react with the concentrated H2SO4, it gives corresponding hydrochloric acid. Or direct combination of chlorine reacts with the hydrogen, it gives corresponding hydrogen chloride. Then hydrogen chloride properties, solubility and chemical properties limited, it's a matter of 5 minutes. Then very important concept, that is oxo acids of halogens and interhalogen compounds. Two important compounds are there. So maximum tomorrow I'll complete. So by Saturday, these two compounds, oxo acids of halogens, very important. Compared to the first starting concepts of 17th group elements, last two pages very important. Oxo acids of halogens and another one is interhalogen compounds. Only 2 pages in our textbook given. Those 2 pages are very important. Either for objective or theory, anyone from that oxo acids of chlorine as well as bromine or iodine, their structures, hybridization, how it exists in solid state or in a salts state or in acidic nature. Then interhalogen compounds structures, availability, stabilities, everything tomorrow we'll discuss about this. Okay, read well, take care. Tomorrow I'll complete maximum.